Hey everyone, welcome to Community Hurricane Preparedness module. This is a really long module and I'm going to break it up into 3 lectures so we can kind of take it apart. It's very important that we get all 3 of these put together because you'll see the meteorology of it. Then we'll talk about the impacts of hurricanes, and then we'll talk about how to prepare for that. So it's kind of a nice little 3-lecture series to put together so that we can really address hurricanes, which to anyone who lives on the coast or pretty much anywhere inland in the eastern half of the United States will have to deal with the impacts of tropical storm systems. And that also is true for Hawaii. Now, let me get this going here where I share my screen. And share my screen. Okay. And we are going to start with this one. Now, this is kind of a weird module. You can get to it the way we did it. It's the 2nd edition, but they have this little arrow, and that's where you get these sessions. So we're going to do introduction and basics. So let's just talk a little bit about the introduction of this. And I've got my handy little Epic pen all here for you. So when we start looking at loss of life, we see definitely a decrease in the loss of life, where this big stuff here is a result of Hurricane Katrina. So you need to know a couple of hurricanes. Katrina would be one of them. It's not the strongest of hurricanes, but it caused the most damage. So we see a lot of that damage also reported here. Now, you might say to yourself, well, why is property going up so much? How are the losses of property going up so much? A lot of it is a result of Katrina, but a lot of it is a result of our vulnerability to tropical systems. Back in the 1900s, Florida had a much smaller population. We didn't have as much urban growth along the shores. Now we know how to build houses along the shore, and people are moving there. And anyone who knows anything about the coastline of the United States is you have poorer communities building on the coastline. Those are very valuable properties, so they're going to be extremely wealthy people with big houses. And anytime a hurricane comes and does damage, it's going to cause property loss very high. Now it says over here that hurricane, it's actually a word, Spanish Caribbean Indian for evil spirits, hurricane. And that's where we get the term hurricane. Now, it's also called a typhoon over here, and that's what we get when we're in the other side of the Pacific. When we're over in Asia, they call it typhoon. It's the same storm. So when we talk about strength of hurricanes and we talk about Category 3 hurricane as a major hurricane, they would call it a super typhoon. Same thing. And there's some other names, sometimes cyclones, baguios. They're all tropical cyclones, an area of low pressure. So with that in mind, we'll continue on. Here. Here's an example of what I talked about with the changes in the population. This is between 1980 and 2009. We see a drop in some of these areas that were affected by major hurricanes, but look at the southeast is just growing considerably. Now here we look at the vulnerability. Here's a house before and after with Hurricane Katrina. So you get some idea of the utter devastation with hurricanes, and we'll be talking about what that threat is going to be. Okay, so we're going to get past the objectives and we talk about the quiz that's going to be coming up, which we'll do after the 3rd one. Let's go to the next unit, which should be the types of tropical cyclones. So the first thing that we want to talk about is on this page. And again, I'm expecting that you would read this, understand that these are areas of low pressure, but we're actually going to start out that's a really big arrow here. We're going to start this way with strength. And we actually are going to start with what we call a tropical disturbance. So we're going to go to that a little bit. A tropical disturbance, CE. And a tropical disturbance, very simple way is if there's any unsettled weather, if we see a region of thunderstorms in the tropics. So we're talking about somewhere between the equator and about 30 degrees latitude. So that would incorporate all of Florida, maybe the far south Texas coast, into the Caribbean, all these islands, because we're going to focus primarily on Atlantic hurricanes. So thunderstorms, and there's tropical disturbance. It then becomes a tropical depression, and they do have a maximum sustained winds, which is not that important. But what I want you to know is that a tropical depression has a closed circulation. So if you recall an area of low pressure, there's my L for area of low pressure, that's a cyclone. And cyclone means that the air is traveling cyclonically, which is counterclockwise in the northern hemisphere. And when we've got that air going all the way around, then we have a tropical depression. Now, the next couple is when we get to the higher level winds. So this, you can write this down, the sustained winds, 34 knots or about 39 miles an hour, and we now call it a tropical storm. It's at this point that we give a storm a name. Okay, so there's an international committee, and let me go ahead and do this for a second. I'm going to hide this, and I'm going to go to hurricane names. And if you do something like this, you can see all the names, and they're cyclical. So every 6 years, they're going to go back. So find your year and take a look at what are the hurricanes coming up, or the tropical storms. Remember, they get a name once they're tropical storm, if they become a hurricane. Then, if you have a famous one, maybe one that does a lot of damage or kills a lot of people, like just a major hurricane, you're going to retire that name. So if you look at the K's, for instance, there is no more Hurricane Katrina. Katrina will never be back on the name list. So when we say Hurricane Katrina, we know one specific storm. We don't ever want to get confused with that. So they have a group where they try to come up with these names from all the areas around the Caribbean, lots of different nationalities, that kind of thing. So can I have a tropical cyclone name for me? Well, you could go to the East Pac or the Central Pacific. East Pac is just a cool way of saying Eastern Pacific. And you can see if your name's on there. I'm not sure if Paul's on there anymore. Oh yeah, 2024, Hurricane Paul could come and wreak havoc in the Pacific Ocean. I'd rather be in the Atlantic, but oh well. Okay, so those are the hurricane names. That's where that all comes from. Okay, now we go to hurricane. And when we get to a hurricane, we are now looking at winds of 74 miles an hour or 64 knots or higher. Remember, and I'm not sure if you recall this, if we've talked about it, but I might as well write that down just for your knowledge. 1 knot is equal to 1.15 miles per hour. These are statute miles. So if you just multiply this by 1.15, you'll get 74 miles an hour. So once it gets there, sustained winds of 74, then it's a hurricane. Now, if you recall, the hurricane is going to be the Saffir-Simpson scale, which we're going to be talking about coming up. All right, and it goes from category 1 to 5. The enhanced Fujita was tornadoes, went from 0 to 5. So we don't have a category 0 hurricane. That would be a tropical storm. And then once we get to a major hurricane, that's category 3, 4, or 5. So that's what makes it a major hurricane. So we start with tropical disturbance, thunderstorms in the tropics, go to tropical depression, tropical storm, and it gets a name, hurricanes, major hurricanes. Okay. Go over here. And here is an idea of the intensity. So they give you some examples of where they are. We expect category 1. They don't usually do that much damage. And I want you to play through this video. You'll see what happens in terms of how much damage there is. Now, category 5 hurricanes, there have not been that many that have hit the United States. So again, I can go to Wikipedia, category 5 hurricanes, US. And we're going to get a list of the Category 5 hurricanes that have hit the U.S. Okay, and I don't know if there's a simple list. You know what? I'm going to go back here because there might be a little bit of an easier one. We can look at a list of all the Category 5 hurricanes. So here's a bunch of them. Now, some of them hit as a Category 5, some of them do not. So that kind of information is kind of important, but you can look back at the historical if you wanted to do that. There's actually a pretty important one on this one. This one hit Puerto Rico. If somebody's doing Hurricane Maria, it took a very similar track to this hurricane. That was the last major hurricane to hit Puerto Rico before Maria did. The ones that I want you to know are the Labor Day hurricane of 1935. This is a Category 5 storm, and I think there you can see its path. It hit through the Keys, did amazing amounts of damage. Just one of the strongest hurricanes ever to hit the United States. Then we had other ones that the next one would be Hurricane Camille. This is a big one. It hit in 1969. I want you to know Hurricane Camille, so write that one down. That one hit near Gulf Shores, Mississippi, which is about where Katrina hit. So two of our biggest hurricanes hit almost at the same location. Then we come up here, some really great storms. Andrew was a Category 5 storm that hit through Florida, and then it came across. And this was a really, into the Gulf of Mexico, this was a really bad one. Now, this was a minimal Category 5. There's some controversy that it probably was more of a Category 4, but they did up it to that. Okay, and then we've got, now Katrina was a Category 5 storm. It did not hit as a Category 5 storm. It hit the United States as a Category 3 storm and still did unbelievable damage, right? The most damage ever. It also caused over 1,800 deaths. So significant storm. Most of that was a result of the levees failing. For those of you who are doing Hurricane Katrina on a paper, that would be something that you'll want to discuss. Now, we also have, Maria did not hit as a Category 5, but we did have Michael that hit as a Category 5 for a short amount of time. But it was a really bad one, hit up near in the panhandle of Florida. So that one you should know. There was one other, I think those are the ones I want you to know. I think there's one that I may have missed. Was it Matthew that hit as a Category 5? Here, we have had a couple of these significant ones, but this caused a lot of problems in other areas. So all of these are just Category 5s, but those are the ones that I really want you to know because they don't hit the United States that often as a Category 5. But that is what we would call damage is catastrophic. Okay. So there you go. There's that scale. Now, the life cycle of this, we can get through, sometimes storms go slowly and get bigger, and sometimes they have rapid intensification. That was actually the answer to one of those questions on the worksheet was, what kind of hurricanes are the most difficult to forecast? And the answer was rapidly intensifying it. So when we look at where do these things go, they're going to be over the warm waters. So what I like about this is we can look at the ingredients that we need for tropical cyclones or hurricanes to develop. So I want to point out some important things on here. It says a pre-existing disturbance. Okay, so what I'm saying is I need a cluster of thunderstorms, a tropical disturbance, something in the tropics. Now, what are those things? Sometimes they're decaying frontal systems, things that we might see outside of the tropics or extratropical cyclones. Maybe even large clusters of thunderstorms known as mesoscale convective systems. But most of them are going to be some sort of disturbance, mostly a disturbance from Africa. So these, let's try to spell that correctly. Africa, or African wave disturbances. And we're going to talk about this a little bit. African wave disturbances. Now, when I say wave, I'm really meaning a trough of low pressure. If you remember what a trough is, it's where the air flows cyclonically. But what I'm going to show you here, and let me go ahead and do this, is that in the tropics, the winds generally flow from the east. Now at the surface, they're northeasterly. These are known as the northeasterly trade winds. So if you recall that from earlier on in the class, trade meaning persistent. And that's true most places in the tropic almost all year long. Upper level winds tend to be easterly, especially in the summer. Remember that easterly winds means from the east. So I'm going to give you a little test here, and I'm going to show you this. And I'm going to make the air flow this way because it's from the east. Is it A or is it B? Which one of these is a trough? So what do you think? Most people, if you're just not thinking too carefully, would say A, because it looks like the low part of a wave. But remember that a trough is where the air spins cyclonically. That is anticyclonic. This is cyclonic. And that's because this is what we call an inverted trough. Trough, T-R-O-U-G-H. Sorry about that. It's an inverted trough. It's upside down from what we normally think about it. So if you recall, if this is in the upper levels, where do we get thunderstorms? Thunderstorms typically are going to be downwind of an upper level trough. And we've said that earlier. Well, that means this is downwind. That's the area, if this is the upper level flow, that's downwind of the trough, because letter B is the trough. Does that sound like this is an important diagram to draw up or to find? And the answer is yes, because this is going to definitely be on the test. So downwind of the trough, that's where I expect there to be thunderstorms. And if this is where there's thunderstorms, then that's where I expect tropical cyclones to begin, or what we call tropical cyclogenesis. Okay. Now, if we've got these disturbances coming off of Africa, so think here, let me do this for you guys. So let me just show you the Atlantic Ocean and hurricanes so you can get some idea. And I think I can just go through images and find something there. So here's where we get these disturbances that come off of Africa. Okay, and you can see there are times where tropical cyclones or hurricanes begin right away. Oops. Oh, I think I made something not right. Hold on a second, I think it's in my pen. I did something here. There we go. Sorry about that. This is where these things are developing and they move this way. They move from the east, so they're easterly waves. Now, there's going to be another thing where we need warm water, and we're talking about SST. SST stands for sea surface temperature. Sea surface temperature of at least 28 degrees. You know what? I'm going to go with 27 degrees Celsius. That's around 80 degrees Fahrenheit. Now, this water tends to be cold, and the water gets warmer the further to the west I get. So east parts of the continents like in California tend to have cold water, and the waters on the eastern side near the continent are colder. On the western side of an ocean, they're warmer. Okay, so there's a gradient, there's a change in the temperature here. So sometimes they start there. This is true when the waters are warm. Other times they start where the waters get warmer. So notice that the Caribbean and the Gulf of Mexico are where these hurricanes really start going, and then they will eventually curve to the around what we call a Bermuda high. So there tends to be big high pressure in the summertime. And so what you think about that is that the air flows this way around it. Okay, and that's known as the Bermuda high. And that steers hurricanes from the east to west here, and then they start to curve north. So let's go back and take a look at what else we need. Notice it says warm temperatures to a depth of about 150 feet. So we need good water temperatures, SSTs that are warm. We do not want winds to change much in direction. So if you recall, the change of the wind with height is known as vertical shear or vertical wind shear. For thunderstorms, we talked about supercell thunderstorms and tornadoes. We want a lot of vertical wind shear. For hurricanes, we do not. We want very little vertical wind shear. So that's important. If I'm looking for hurricanes to develop and I see a lot of shear, I'm not expecting tropical weather. When the shear goes down, then I start thinking maybe this will develop into something tropical. It says it needs to be away from the equator because I need the Coriolis force. So if you are writing down the ingredients, you say you want the Coriolis force. So don't want to be affected by hurricanes, go live on the equator. You start going 300 miles away from the equator, now you can get spin that the Earth is helping. So that's where the spin comes from. And then it says the atmosphere cools enough with height to allow thunderstorms. So really what we're saying is that we need instability. That's what that means. And we need moisture. So those are two ways. We have an upper disturbance that provides lift. So we're looking for areas of thunderstorms developing where there's warm water and there's no vertical wind shear in the tropics. And that's where we get these tropical developments. Okay, so that's what this page is all trying to say to you. Okay, now we can go a little bit faster. We can just see that we get development. You know, eventually you develop the eye, which we'll talk about when we get into the storm structure. But when you see an eye, that's usually about where a hurricane is. You don't tend to see an eye in a tropical storm. If you see an eye, then it becomes a hurricane. Sometimes the eye is very visible. There's a lot of different sizes of the eye, but that's what it is. All right, now what's going to cause a storm to end? So take a look at these. Now, keep in mind that most are going to turn and go to the northeast. If they turn here, they're going to hit the Gulf Coast or off the East Coast, depending on where they turn. And a lot of times for forecasting, that turn is a really tough forecast. Over here, they tend to go across in the Pacific. And notice that they weaken here. Well, why is that? This water here is very warm, but over here in the general Pacific, it's much cooler. So I want a storm to die or weaken. First thing you want is cool water. So that's number one. Number two is to have land. What we're going to find out is that air converges in the center of a hurricane and it needs the moisture from the warm water. When you bring it over land, you lose its energy source, which is warm water, the latent heat, if you recall that term. But we also increase the amount of friction, which slows the wind down. So friction is what we get over land, and we lose its fuel supply. We lose its source. The third thing that will weaken it, at least, or even stop it from developing would be vertical shear, vertical wind shear. If we have vertical wind shear, that doesn't necessarily kill it, but it will weaken it. So this is like a tertiary, third level factor. These are your two primary factors. Or maybe I should have just said secondary, huh? Okay. Now the structure, and we'll talk about these in some of the products when we look at the wind field. This is basically saying in here, in this dark red, is where there's hurricane force winds, and the orange is when the winds are tropical storm force. So when we have a threat, right, it's not just where the hurricane is. It's not a pinpoint. There's a large area where there's hurricane force winds, and then a much larger area with tropical storm force winds. So that's something that you want to consider in the structure of the hurricane. Now, we do have inflow and outflow, and I think we talked about this before, that a hurricane is like putting the lid on a mayonnaise jar. So if you grab the jar with your right hand and turn it counterclockwise, that's the way the air is flowing down low. If you tighten the lid with your left hand on top, then that's going to be cyclonic. So we actually get cyclonic flow down low, like that, and then we get anticyclonic flow aloft. It tends to diverge anticyclonically. Now, as the air is flowing in, we are picking up warm water and moisture, and then it becomes cyclonic in here. If we go over here, we can kind of move our camera height to see that cyclonic flow. If we go to the rain bands, these are going to be thunderstorms that form in what we call rain bands, or more commonly, we call them spiral rain bands, because the air is coming in and converging toward the middle. So we've got convergence in toward the middle, and along here you might get bandings of thunderstorms somewhere around here, and those are called spiral bands. And that's what gives it sort of this leg, octopus-like look. Okay? We have the eye, which is clear. The result, the air is spinning around so fast, it's got the conservation of angular momentum, like an ice skater. When she pulls her arms and legs in, she spins up faster. That's a smaller radius, spins faster. So that's what's happening. But it spins so fast that it gets centrifuged out. You know, just like something spinning around, you're going to fly out. And then there's air that sinks in there for the eye. And that's usually why you can get clear skies in the eye. And it's very calm in the eye. So something really important is that the eye is surrounded by the eye wall, which is the heaviest precipitation, strongest winds. Those are the strongest cumulonimbus. Cumulonimbi, right? These are the strongest ones in the eye wall. Sometimes a local weather service office will issue an eye wall warning, because if you're going to get really significant winds, that's where it's going to happen, in the eye wall. Okay, back to the menu, and then we have outflow, which tends to go high levels, kind of goes anticyclonic, so the storm is actually spinning kind of this way with different hands. That's what you should know. Okay, so a little bit of information on the eye. You can take a look at some different eyes. A lot of times this eye wall will recycle. It'll go through an eye wall regeneration cycle. You don't need to know that for my test, but if you watch this little video on Hurricane Ike, you can see it. Sometimes it tightens and then it redevelops. It's pretty amazing. And because of this, these eye walls that form and reform, they tend to be correlated with strengthening hurricanes before it reforms. So a hurricane's coming on shore and the eye's tightening, you can jump up 1 to 2 categories stronger on the Saffir-Simpson scale. But if it starts to recreate an eye wall replacement on the outer part, it can weaken considerably. So that's why we're not very good at strengthening or weakening of a hurricane, because we don't know when the eye wall replacement cycle is going to take place. And there's some text about that there. Spiral rain bands, sometimes within the spiral rain bands, there's going to be tornadoes. So that's something that you would need to know too. So usually when there's a hurricane approaching, all that stuff is coming from National Hurricane Center, but the Storm Prediction Center may issue tornado watches also because there's always a threat for a tornado, which is a specific phenomenon that Storm Prediction Center is going to forecast for. So if we look at storm motion, the idea is this, right? Let me get my pen back. If it's going around an area of low pressure, like this, and let's say the winds are 100 miles an hour in the hurricane, but the storm is moving this way at 15 miles an hour. That means that relative to the ground, the air over here is actually at 115 miles an hour. Whereas the wind here is kind of going against the way it's moving, may only be 85 miles an hour. So when you're on the right side, the winds are going to be stronger because you're adding the speed of the motion and the speed of the winds, and it can be stronger. But this is where the water is also being pulled inland, sort of like blowing on a plate. That's known as the storm surge. And that water is coming onto land and it inundates the land. Remember, inundation means water on land. So this is the right side, really that front right quadrant is where most of the concern, like this is the area where most of your concern is going to be, the right front quadrant. Okay, so read through that text, it's in there. It should explain that pretty well. Now, as far as the size, some are small and potent, some are large and potent, or some are weaker and large, right? It doesn't really matter. Camille was a small one. It says, do not focus on the location and track of the center because you need to think about how much are the hurricane force winds, how wide, and the tropical storm force winds as well. So there's the circulation again. Remember, it spirals in toward the center, and then this is what's going on at low levels. But if I look at upper levels, this is the way the air is flowing outward. So that's outward at upper levels, inward at lower levels. Okay. Now, this is kind of a fun one. I want you to do this, and what you'll probably need to take a screenshot, but I'm going to give you 2 cities to aim a hurricane. So what you're going to do is you're going to take the low and you're like, all right, let's put the low. I'll start at one of these 2 places. I'll put it there. And I'll put the high pressure there. How to aim a hurricane? Why is this now? Oh, here. Start the hurricane there. Take the high pressure there, maybe. Put the low pressure there, maybe. And then I start this, and it shows you where the hurricane's going to go. Notice it wants to go in between the high and the low. So it goes around this Bermuda high. And so what I want you to do is I want you to find, I guess I hit New Orleans with this. So where would I want to position? I can reset. Where do I want to put the high and the low so that I hit Miami and I hit New York? Let's try that. Miami and New York. So figure out where you would have to go and see if that works. And then just once you put it in there, you can just show me a little copy of that. Okay? So aim the hurricane. It's kind of a fun thing. I don't know if they have the wind on here. I kind of missed that. They updated this. Okay. Now, when do these things start? Okay, when is hurricane season? Okay, hurricane season is in the United States for the Atlantic hurricanes is basically June 1st to December 1st. And that's the cumulative number of systems. So we start to see it, the peak months would be August, September, October. Those are your 3 most important months. Okay, so you can get some in May, that happens. You can get them in December, that happens. But those are your primary months. Those three in the middle are the most significant months. Okay, and if you take a look at hurricanes, this is a little bit harder to understand. When it looks at major hurricanes, not much difference. We had a pretty good decade in the 2000s, but all hurricanes, we're starting to see them more because we've developed satellite. Remember, we talked about satellite, and we started developing satellite back here someplace. So we actually could use satellite to determine whether or not there's a hurricane. So there's our season, peaked at around September 10th of hurricanes and tropical storms. You can see we get some in December, we can get some in May, but that's just something to think about, okay? There's something else to think about. Origin zones. In June and July, we start out in the Gulf of Mexico because that's where the water is the warmest, and we start to go into the Caribbean. By the time we get August, it starts extending further to toward Africa, and then September is where the waters are warmest out here. When you are getting these big hurricanes that come across, there are some islands over here called the Cape Verde Islands. That's the Americanized pronunciation of Verde. So, but that's the Cape Verde Islands. And so Cape Verde season are the big hurricanes that you see coming, you know, a week, 10 days in advance and just barrel across the Atlantic. And that would be the Cape Verde season. Those are usually some really big, significant hurricanes because that's at the peak season. That's where the waters are warmest. Here's something you should know. The warmer the water, the potentially stronger the storm is going to be. So let's take a look at something that I think is kind of important. I'm going to open up a window here. We've gone to our text pages before. If you go to climate page, you will see something that is important. You have SSTs. And I'm looking now here at the sea surface temperature. Notice that the warmest waters in the world are out here in the Western Pacific and much colder along the west coast of the United States. The same would be true when we look at the Atlantic. Now, to look at the Atlantic, I probably need to go over here and I can look at the Atlantic Ocean here and see the same type of thing. Okay, where warm waters in the Caribbean and the Gulf of Mexico, much cooler along the African coast. But because Africa is shaped kind of interesting, we get this warm water near the equator in this region and warmer waters here, cold coming from the north, but that water. So here's the Cape Verde Islands right over there. So disturbances are going to come, and as they go across, they get to warmer water, and then that's when you start to get that turn in the warm water. So they get really strong in our area of the world. Keep in mind that not only do I show you the actual sea surface temperature, I can show you the sea surface temperature anomaly. And so I'm looking at here are departures from normal, where I've got colder than normal water here, a little bit warmer than here, but most of this area is about normal. So right now it's not looking like there's anything major. It's a little bit cool along the coast. There was a hurricane and pretty much tropical storm Elise that just went through, and that churned up the water, brought some cold water up to the surface. But that's how we kind of consider these things, looking at not just the temperature, but also how does that compare to normal. Okay. Let's go to the next. Once we get into December, we start to cool down. Now, I want you to go through these questions. These are all really good questions. You're going to, and I would like you to put those into your notes. I think there's one or two in here that are kind of tricky, so be careful on that, okay? And then we go to the next unit and we talk about the tropical cyclone threats. Okay, so that's the hazards, and we will start that on the next unit. But that's what we have for the first on basics. So go ahead and write up notes on that. That's the meteorological basics. If any of you are doing your paper on hurricanes, you really need to be considering kind of a quick summary of the basics, but focus that with your storm in particular. The rest of you, enjoy your notes, and we'll see you for part 2.